Hey scholars, I hope you're doing well today. Today we're going to talk about rotations in the coordinate plane. This lesson is going to be a little bit tricky, and I totally understand that. Just make sure you take in as good a notes as you can, have graph paper with you, and look at the slides that I attach on Google Classroom as you watch the video. If it feels tricky to you at any point, don't get overwhelmed. Just keep taking good notes. Maybe rewatch some parts so you understand what I'm saying a little bit better. Let's get going. So a rotation is a transformation that turns a figure around a fixed point, and we call that the center of rotation. So it can be on, inside, or outside of the figure. So here we have some examples. We have the center of rotation here. It would be at this point O. It's rotating around this point O. And then we have a point right here. This point P is outside of the figure, so that would be the point of rotation. The figure is rotating around that point of rotation, which in this case is outside that figure. Okay, so the angle formed by the vertices of the figures in the center of rotation is called the angle of rotation. Here we have a 90-degree angle of rotation. So this figure is rotating 90 degrees counterclockwise, so the opposite way a clock goes, right? It's rotating 90 degrees counterclockwise. And then here we have a center of rotation that is actually inside the figure. Alright, so that's also a 90-degree rotation, just the center of rotation is inside the figure. So now let's talk about angles of rotation a little more. So if the figure is rotated counterclockwise, it has a positive angle of rotation. So if it's going counterclockwise, so again the opposite way a clock goes, so here we would have in a counterclockwise rotation, and this is 270 degrees, okay? So it's starting in the first quadrant. You can see this green triangle starting in the first quadrant and going 1, 2, 3 quadrants right here to where it would map onto that purple or purplish pinkish triangle. Remember, I'm kind of colorblind. Now, if we went the other direction, if this green triangle went in the clockwise direction 90 degrees, it would still end up in the same spot as that 270 degree rotation. It would go 90 degrees clockwise and land on that purplish pinkish triangle. So we would actually call this a negative 90 degree rotation because the negative direction, as you can see here, if it goes clockwise, it has a negative angle of rotation. So if you see a negative 90 degree angle of rotation, it's going clockwise. All right, so, and also, remember, see how we landed in the same spot, whether we went 270 degrees in the positive direction or 90 degrees in the negative direction, okay? So if you can say this, 270 degrees minus negative 90 degrees, then you end up with 360 degrees, okay? So if you can subtract them, and they add up to 360 degrees, then those rotations will end up in the exact same spot. Now I know that might be a little bit of a tricky concept, but just keep following along with me, okay? So now we're gonna take the triangle XYZ, which has coordinates x is 4, 0, y is 3, 2, and z is 5, 2. We're gonna rotate that triangle 90 degrees about the origin to get triangle x prime, y prime, z prime. All right, so I'm going to start off by plotting the pre-image. So we've got 4, 0. So that's going to be point x, y is 3, 2. And then z is 5, 2. 5, there we go, right. So that's going to be point z. Now, I need to connect the dots. Let me do that real quick. Now, pay close attention here. So I'm going to just start with point y. Now, it is 2 units away, so 1, 2 units away from the x-axis. Point y is also 1, 2, 3 units away from the y-axis. So when I plot point y prime, I'm going to switch that up. It's actually going to be 2 units away, not from the x-axis, but from the y-axis. And 3 units away, not from the y-axis, but from the x-axis when I plot it in the second quadrant. Okay, so it's going to go 90 degrees and move into the second quadrant. So, like I said, 3 units away from the x-axis. So 1, 2, 3 away from the x-axis, and then 2 units away from the y-axis. So 1, 2, 3 away from the x-axis, 1, 2 units away from the y-axis, and that's going to be y prime. One more time, because point y, and let me draw that a little better. I'll put point y right here. Because point y was 2 units away from the x-axis and 3 units away from the y-axis, I'm switching it up in this quadrant. It's going to be 2 units away from the 2 units away from the y-axis and 3 units away from the x-axis now. All right. Now hang in there with me. I'm going to look at point Z now. Point Z is 2 units away from the x-axis and 5 units away from the y-axis. So point Z, I'm going to put it in this next quadrant, 90-degree rotation. So because point Z is 5 units away from the y-axis and 2 units away from the x-axis, it's now going to be 5 units away from the x-axis and 2 units away from the y-axis. So I'm going to do this. I'm going to go 5 units away from the x-axis, so 1, 2, 3, 4, 5, and then 2 units away from the y-axis, so 1, 2. And I'm putting it in the second quadrant. So when a figure is moving 90 degrees, it's going to move one quadrant over. And we're going again in the counterclockwise direction. So see how the points are moving into quadrant 2, from quadrant 1 to quadrant 2. Alright, now lastly, point X is 4 units away from the y-axis, and it's on the x-axis. It's 0 units away from the x-axis. So now it's going to be 4 units away from the x-axis. So 1, 2, 3, 4. And then 0 units away from the y-axis, because it was 0 units away from the x-axis here. So you're just basically swapping the axis, but keeping the distance the same. All right, so we have, let me write y prime right here. Now we have rotated this figure 90 degrees. Now, what is the center of rotation? Well, the center of rotation is right here, the origin. And something I didn't mention earlier is that each of these points is going to be the same exact distance from the origin, from the center of rotation. So, because X is 4 units away from the center of rotation here, it's 4 units away in this other quadrant, okay? It's always going to be the same distance. And this distance from y to the origin and y prime to the origin, that distance is going to be the same. All right, now that you made it through me showing you kind of how a rotation works, we are going to learn some rules. Here's your reward. We're going to learn some rules and some tricks for making those a little bit easier. But you got to hang in there because you got to understand these rules. Once you do, you'll think it's a lot easier. All right, so we're going to look at triangle ABC, and I'm going to first just write down the coordinates of these points. Point A has coordinates 3, 7. B has coordinates 8, 5. And point C has coordinates, let's see, 9, -3. So I'm going to do a 90-degree rotation, and I'm going to say that that's going to be triangle A prime, B prime, C prime. And then I'm going to do a 180-degree rotation. That'll be triangle A double prime, B double prime, C double prime. The 270-degree rotation will be A triple prime, B triple prime, and C triple prime. All right, so that's what I'll name each of those triangles. I'm going to draw them all on the board so you can see how this triangle ends up rotating. So for the 90-degree rotation, we have our regular points. They're in the form x, y. So x value, y value. And then to find A prime, I'm going to look at this rule for a 90-degree rotation. So the point x, y is going to transform to the point -y, x. So basically what's happening here is the x and y are they're gonna swap. All right, the y is gonna move to the x is gonna move to the y. But when the y moves into the x value, it's gonna become opposite as well. So check out what I'm saying here. So 3 and 7, they're going to swap to 7, 3, but then the 7 moves into the x value and also becomes opposite. It goes from positive to negative. Same thing's going to happen with b prime. So b is 8, 5. The y value is going to move into the x value and become opposite. So it'll be negative 5, 8. That'll be the coordinates of b prime. C prime. The y value is going to move into the x is going to move into the y. And remember, the y value moves into the x and becomes opposite. So negative 3 is going to move into the x value and also become opposite. So it goes from negative to positive, becoming positive 3, 9. So this is all for the 90-degree rotation here. I'll write that down here. This is all 90-degree rotation, all these points above it. Okay. So I'm going to plot those points. So now A prime and B prime moves from the first quadrant to the second quadrant. C prime moved from the fourth quadrant to the first quadrant. Okay, so when you go 90 degrees, you're going to move over one quadrant. Each point is moving over into the next quadrant counterclockwise. Remember, these are positive angles of rotation, so we're going counterclockwise. All right, so now I'm going to find A double prime using in A prime, B double prime, and C double prime using the 180-degree rotation. So that rule is actually the same as the rule for a reflection about the origin. XY becomes negative x, negative y. There's no swap. They just both become opposite, just like a reflection across the origin. So, I'm going to look back at the original points. Looking back at the original points, I'm not worrying about A prime, B prime, C prime. I'm looking at the original points, the pre-image. So they're all going to become opposite. So negative 3, negative 7. So 3, 7 became opposite, negative 3, negative 7. To get B double prime, 8 and 5 are both going to become opposite. So negative 8, negative 5. And then to get C double prime, 9 and negative 3 are both going to become opposite. So we're going to have negative 9 and then positive 3. It goes from negative to positive. All right. Now, for a 270-degree rotation, which I'm going to do right here, we're going to have a triple prime. And we're going based off this rule, x, y becomes y negative x. So we're having another swap again, but instead of the y value moving into the x value and becoming opposite, the x value is going to move into the y value and become opposite. All right, so let's see. We're going to look back at our original points again. So looking at A, so we're going to have a swap, and then at 3, which is in the x spot, is going to move into the y and become opposite. So we're going to have 7, then negative 3. B triple prime becomes, let's see, we're going to have a swap, and then, so 5, negative 8. C triple prime, we're going to have a swap, and then the 9 is going to move into the y and become negative, become opposite. So negative 3, negative 9. So that's for 270. Now, I forgot to graph or plot 180-degree rotation. So let me graph these points. So you can start to see how it's rotating all the way around. And again, these points from A prime, B prime, C prime, they just moved over one more quadrant to become A double prime, B double prime, C double prime, which I forgot to label. All right, last one. I'm going to plot the 270-degree rotation. So you can see how the pre-image rotates. Looks like it's rotating all the way around the origin, that point of rotation. You can see it rotating all the way around. And we can perform those rotations just using these rules. So I hope that was helpful for you. I know some things are challenging, especially with this topic, but we'll go over them in class. Just come with questions and maybe rewatch different parts of the video that you feel like you probably struggled with. And look through the slides that I've attached on Google Classroom. They'll help you. Okay, so good work today. Thank you, Collegiate Scholars.